Bismillahirrahmanirrahim, lecture number 20. And today we'll be continuing with our previous lectures, and that was about the alternative energy resources. Today, our topic of alternative energy is about the wind power or the wind farms. Um, a wind farm or wind park is a group of wind turbine. They are situated in the same place. If imagine a large wind farm, we can have hundreds of individual wind turbine, and that would be covering into extended area, 100 of square of mile. But if you can check the picture over here, the land between the wind turbine that can be used for the other purposes, and that mainly for the agriculture purposes, or even you can have like different other activities. So wind farm can be located onshore and can be located offshore. So onshore, that mean like it can be located on the land, or offshore, that would mean like that it can be located on the sea. Uh, Many wind farms that are operational nowadays in the world have got hundreds of, as we said, like hundred of thousands of wind turbine. The biggest wind turbine, or the biggest onshore wind turbines or wind farms, are located in the United States, China, and India nowadays. The Gangsu wind farm is the largest wind farm, onshore wind farm in the world. It has the total capacity of 8,000 megawatt as per 2020, sorry, 2019, with a goal of 20,000 megawatt by 2020. Although it has got a goal of 2020, but whether it has reached that goal or not, it's yet not actually known. So still, what we are saying, like they were actually installing so many wind turbine in Gangsu, and that was actually to meet the target of 20,000 megawatt by 2020. The second largest wind turbine or wind farm is actually in Mapandal, and that is in India. That has a capacity of 1500 megawatt. So if you can just compare this wind farm with the Gangsu wind farm, so that has got the installed capacity, already plate installed capacity of 800 megawatt, while the second largest is 1500 megawatt. Um, it is somewhere in the North Indian side. The Atlas Wind Energy farm, which is actually the third largest, and that is outside the China, that has got the capacity of 1320 megawatt as of 2019-20. By December 2020, 1218 megawatt of Hornsea wind farm in the UK is the largest offshore wind farm in the world. That means like we are talking about the wind farm which is actually inside the sea. And obviously these are increasing day by day. There are many wind farms that are under construction, and these individual, if I would say like these wind farm might be having a large capacity or small capacity, but there are so many wind farm, wind energy turbines actually getting installed in the world nowadays. Uh, Normally, the design of a wind farm, they depend on the economic wind speed, and that is what we can imagine. We can say like it is around 16 kilometer per hour or mm, 10 miles per hour, or greater, obviously. The ideal condition would be not just just a speed, but a near constant flow of non-turbulent wind throughout the year. We do not actually just looking for the just a sudden burst of a wind, and we do not have got any other, like I would say, like availability in the next year. But we would be actually monitoring these sites for throughout the years, and once we are successful, or once we are actually sure about the wind data, then it would be obviously looking to install the wind turbine or wind. Typically, normally when we are increasing the height, the wind speed increases. So doubling the altitude of the turbine would increase the speed by 10%, and obviously the expected power by the wind turbine by the 34%. Uh, Looking at the wind farming, obviously the wind farming have got two. The main component of the wind farm is the wind turbine. There are normally two different kind of a wind turbine, and that is the horizontal axis wind turbine and the vertical axis wind turbine. So what is actually a wind turbine? A wind turbine is a device that convert the kinetic energy from the wind into the electrical energy. The wind turbine used for charging the small batteries are referred as the wind charger. Um, and as I said, like that can rotate horizontally and that can rotate vertically about its axis, and that is what we call it as a horizontal axis wind turbine and vertical axis wind turbine. The horizontal axis wind turbine have got the main rotor shaft or electrical generator at the top of the tower, and that is must be pointed towards the wind. What actually we mean, like if I've got the horizontal axis wind turbine, so we have got the wind generator, sorry, the electrical generator, which would be located at top of tower, uh, and obviously it will be towards the pointed towards the wind over here like this. Uh, the small wind turbine, they have got somewhere vanes over here, or if I would say like something like this, and which is actually used in driving or if I'm moving the wind generator or the wind turbine according to the condition of the air or according to the direction of the air. While the large wind turbine, which are nowadays very common, they cannot be actually moved by these just small vanes. They have got the servo motors and they have got the sensors which are actually installed in the wind turbine over here, and then they are responsible for the uh, quicker rotation and they are responsible for the drive of the electrical generator. The vertical axis wind turbine, they have got the main shaft that is arranged vertically. One of the advantage of this arrangement is that the turbine does not need to be pointed into the wind to be effective, and that's what actually the main advantage of this wind turbine. So this is more important to the places where the wind condition are normally so a little bit turbulent, or the wind condition or the wind normally changes direction too often. So these are the wind turbine, which are actually more towards the wind condition, which are not so stable. And obviously, they are more likely the small wind turbine, and they are more. Sometimes it is actually a house-top situated wind turbine, or the wind turbine which is actually installed at the top of the building. So they have got the generator which would be somewhere it can have an advantage like the generator can be installed over here at the bottom of the tower, this is quite easy when we are maintain when we have got the maintenance in the wind turbine, while for the horizontal axis the wind turbine, the tower is so high, or if I'll say like the height of the tower is so much, like it is sometimes difficult to maintain or have a maintenance of the wind generator. While for the vertical axis wind turbine, the wind generator is installed at the bottom, and it is quite easy to 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 have a maintenance or have a repair. As I've said, like does not need to be pointed towards the wind. So if the wind is actually on this direction, or which is actually on this direction, or any other direction, so the it will be actually rotated accordingly. So this is actually a little bit about the two wind type of wind turbine, but for a hi- for a big wind farming, or the wind actually or the places where we have got quite a good wind, these horizontal axis wind turbine are quite common. So horizontal axis wind turbine are normally common because like the height of the tower can be increased accordingly, and obviously the rotor diameter can be actually changed, or can be increased. That having said that, it is because like the wind energy, as we have said, like wind energy is converting the kinetic energy of the wind into electrical power. So that means like the more the wind is, the more the electrical power would be. The advantage of the wind energy is like energy sources is definitely free. We do not have got no carbon emission, we do not have got any pollution, we do not need to use any water. Yes, there is actually added uh, disadvantage to them, and that is because whenever the wind in a wind turbine, or where the places where the wind turbine is installed, normally there is actually a little bit of a noise pollution, and some reports like they have got a little bit disadvantage towards the life of the birds and so on and so forth. So that's a little bit of the disadvantage side. But on the advantage side, we have got so many advantages of the wind turbine or wind energy. Looking at the wind energy of of Pakistan, Pakistan is normally having quite a good wind. You can check from this table as well. Uh, Quite a good wind of like 5 to 7 meter per second wind is available in coastal area of Pakistan and somewhere in the Chatral as well, Chatral, Dil, and so on. But till 2013, Pakistan did not have installed any of the wind turbine, or say like Pakistan contribution towards the wind energy was quite low, or there was even nothing. But after 2013, there was so much investment in the wind energy, and now Pakistan is getting pace or getting installed, or the wind turbine are getting installed in Pakistan. They are mostly installed in Jimpi sector. They are mostly installed in the Badin sector, Tata sector of the coastal area of Pakistan, Sindh. And as of uh, 2018, wind energy capacity of Pakistan, uh, and even that's in December 2019 as well. Wind energy capacity of Pakistan stand around 1237 megawatt. They by 2020 they have going to increase another 500 megawatt of energy through the wind energy or through the wind. Currently, Pakistan renewable energy, the wind power share in the Pakistan electricity is 3%. The government is looking to increase the share of the renewable energy and plan to add a little bit more, 3.5 gigawatt of energy capacity by 2018, but yet is a little bit long way to go. It is because the Pakistan Meteorological Department conducted a survey back in 2013 that was titled as Wind Power's Potential Survey of Coastal Area of Pakistan uh, by Ministry of Science and Technology. And they say like if we are looking at the coastal area of Pakistan or the Jimpir Garo sector of Pakistan, Sindh area, they have said like we have got the potential to cover if we can have got the potential to cover 9,700 square kilometer, then we can have a wind energy of 43,000 megawatt, which is quite a huge amount of energy for Pakistan. The current installed capacity or the current installed electrical energy in Pakistan is around 25,000 megawatt. So if we are looking at the wind energy potential which Pakistan have got is quite or is a little bit, I would say, like double than the installed capacity. So that could actually make a quite a huge difference. Uh, by that's I say like by 2030, Pakistan have made a target of 9,700 megawatt by 2030, and obviously added by 3,730 megawatt by 2020, which actually they are getting installed. There are some MOU signed with the Turkish, and obviously there are some MOU signed with the Chinese as well. About the Ministry of Science and Technology, they were looking to invest the around like 850 million, and that they were looking for the payback period of some 8 years. The capital cost of wind power project range that come up around like 40 to 50 million per megawatt, which is quite a cheaper in any of the power plants power generation capacity. Uh, this give the level cost of the wind energy generation would be around 2.5 to 3 uh, rupees per kilowatt hour, which would be the cheapest electricity power unit in Pakistan. Like if you are looking for the hydro as well, they are around like 4 to 5, which is 4.5 something. So obviously this would be the cheapest energy available if we can achieve this much this target. Now as I've said, like wind energy or what is actually a wind turbine? Wind turbine is converting the kinetic energy of the wind to the electrical energy. So that give us the wind power. And what is actually the wind power? Wind power is the kinetic energy, and if we're looking at the kinetic energy, so that would be half into mass into velocity square. Then we have to multiply with the density of the air, or mass density of the air, or the of if I say like the mass which is actually going on the blades of the wind turbine. So that would be the wind energy density, mass density of the air into the kinetic energy. And then obviously if we are looking at the power, so that would be the we would be multiplying with the area of the windmill as well. This come up as the power would be proportional to the cubic of the wind speed. So for twice wind speed we get 8 times of the power. So as we have said a little bit earlier as well, if I would increase increase the height, it would increase the wind speed by 10%, and it would expected power by 34%. So this is what actually a simplest formula we can use, like when power is actually proportional to cubic of the speed of the air. This is the wind size evolution which we have got throughout the years in the 19th century. And that's if I'm saying like all this windmill size evolution, they depending on the property of the material. So what we have got, like the most advanced material goes actually, the most the size of the windmill will be increasing. So the good material would be definitely required, or good material would be definitely required to capture the wind flux or the wind energy. And obviously this is vice versa, like not good material will be not able to withstand with the high inner wind power, obviously. That's because in 19th century, if we have got the windmill, there was quite limited, and that was quite limited to, let's say, 1 to 12 kilowatt. And obviously, as the material progresses, 1919, if you can imagine. So as the material progresses, the size of the windmill increases, or the size of the turbine increases. The height of the turbine would be increasing, and the rotor blade diameter would be increasing. This is actually, if you can check, like at the background, this is the size of different monuments that they are showing. This is the London Eye, and obviously this is the Liberty statue, and obviously this is what we call it as Eiffel Tower, and so on and so forth. Anyway, so that means like the if the height of the tower is increasing, the height of the tower is increasing, rotor blade size is increasing, so the capacity of the windmill is increasing. By 2025, they are expecting like we would be having a windmill which would generate each windmill would be generating around 13 to 15 megawatt of the power. We have got like some news over here, like even as a biggest wind turbine which is nowadays installed in different area, if one rotation of that wind turbine would actually cause or if it would provide energy to a house, a single house for 2 days. So a single rotation can give you energy for a house for for 2 days actually. So that means like the more the size of the wind turbine is increasing, the more the energy we can harness from the wind, and obviously the more the capacity of the wind turbine. Uh, but normally the windmill, if we design the windmill according to the available wind speed or available wind flux we will be having. But obviously, there is not always that much amount of wind available, or if I would say like not available throughout the day or throughout the year. So the wind energy or the it is capacity definitely is not always as rated with speed. We say like the power is proportional to wind speed, cubic wind speed. The output is still less than the capacity itself. And below the cutoff speed, obviously what we have said like 16 km per hour, below that cutoff speed, we would be having not a good, I would say like a energy, or even sometimes the windmill does not function. Uh, Wind speed are normally more often below average than the above average. This is what actually we have got the, if we, the power is increasing as the height is increasing this direction, the power is increasing in this direction, and obviously the wind energy or wind speed is increasing in this direction. So you can check like as we are increasing the height, the wind speed is increasing and the power is increasing. And yes, there is one more thing we need to say. Like yes, this is what actually we have got below cutoff wind speed. We do not have got the power over here. Yes, we have got in power increasing from, let's say, from 5 meter per second wind speed, and there is actually again another cutoff which we call it a critical cutoff, obviously. So when we do not have got the, we have got the production of the wind blades as well, production of the generator as well, and after that one we have got the storm protection shutdown as well. So if we have got a wind speed greater than 25, or wind speed equal to 25 meter per second, we have got the storm protection shutdown. Obviously that will damage our generator, and that would damage our blades as well. Moving forward, like if we're looking at the wind power of the world, so you can check from this graph, like wind power of the world is increasing quite exponentially. Like when I say, like when I started this wind energy lectures back in, let's say, 2012 or 14 something, so you can check like back then the wind total installed capacity, cumulative capacity of wind energy was around somewhere around 360 gigawatt in the world. And then in the next few years, it reached to 500, around 500 gigawatt. And obviously in 2018, actually, it goes to around 591 gigawatt. While there is actually a little bit unpublished data of 2020, it is around like 650 gigawatts. So you can imagine like the wind energy, the installation of the wind turbine, wind energy is actually increasing exponentially, and that is because of the advancement in the material. That is because of advancement in the technology, in the advancement in the sensors, and obviously there are some data available to the wind energy corridors. So that means like installing that wind energy or installing the wind turbine is getting quite easier, obviously, and it is actually more economic. This is what we can say like the share, the top 10 cumulative capacity by December 2016. Uh, by that by this graph, it's say like the total installed wind energy in China was around 168,000, around 116,000 wind energy was installed in China. That come up as 34% of the global share in the wind energy, while USA has got 16% global share and installed capacity was 82 somewhere, Germans, and so on and so forth. But having said that, but the data which is available for 2019 now, the installed capacity in Chinese are around 250 plus now, 250,000 megawatt plus now, and they are sharing at the total global share now for the China wind energy is more than 37%. Um, Having said, the percentage of electrical power which actually any specific country is using. So Denmark is using its 52%, more than 52% of energy from the wind. United Kingdom is actually reaching around 19.81% from the wind energy, and also on so forth. The United States is actually 6.89, and Chinese are 5.41. It does not mean like the 6.89 is quite a low figure, but the total energy share of the wind in electrical power, that is 6.89 and 5.41, while the other share might be different. And or in other words, I would say like the total electricity produced in China and US, they are quite big. So the share of the wind energy is around 6.89 and 5.41. India is actually pacing up with the rest of the world, and it is having uh, 4.06% of the energy that's been produced by from the wind. Pakistan have got up till December 2020. Pakistan have got the share of 3 point, around 3.5% energy is actually getting from the wind. So now a little bit concluding remarks about the wind energy and the solar energy. So if I'm looking at the comparative analysis of the solar and wind energy, this is solar and this is wind. So solar have got high maintenance cost. They have got many parts in it. They have got many things in it. So they actually work in a high temperature zones. They take up a lot of land, and obviously the lands which actually they are taken, that cannot be utilized for any other purpose. That could be only and only utilized for the solar energy. And obviously, they work only and only when there is sunny area or when there is sun. And there is also one of the things that actually we can say like the storage capacity. If we are increasing the storage capacity of the solar, so that would be added cost, and obviously that is sometimes not possible. So solar is having this kind of problems or this kind of advantage and disadvantage. While on the other hand, the wind energy, they have got low maintenance, few parts, only generator and blades and tower. They take up little land. Obviously, they take up little land, but the land which is actually taken by them can be, or the land between them can be used as well for the agriculture and as like any other purposes. So they take, in that perspective, they take that little bit, and it work whenever it is windy. So it does not depend on the sun, or it does not depend, and whenever it is actually windy, so we can have the energy output from the wind turbine. So this is the reason, like the many countries, and that include Pakistan and India as well, many countries they are investing not much in solar but in wind, where Pakistan and India and in this continent, subcontinent, they have got quite a good sunny area, quite good sun in here, but they are more and more investing in the wind energy, and that is because of the many advantage which is associated with the wind. I hope you understand this wind topic. Yes, I would encourage you people to look at the different websites and different energy websites or energy in articles that is available on the internet, so you can have much more details or much more breadth of this wind energy. Have a nice time.